Hi, welcome all. To take a topic, basic fundamentals for electromagnetic field theory, EMFT, in BTech fourth semester. So we are going to start with basic fundamentals. The prerequisites to understand the electromagnetic field theory is vector calculus, complex variables, and course is focused on foundations of electromagnetic field theory. Course objectives: on the completion of this course, students should gain through understanding of time varying field, Maxwell equations, time harmonic fields, and plane electromagnetic waves. Understand the operating principle of resistors, capacitors, and inductors. Be able to analyze simple electronic equipments utilizing electromagnetic concepts. The references: the Principle of Electromagnetics, 4th edition, Matthew Sadi. Other recommended books: Electromagnetic Fields and Waves, 2nd edition, David K. Chang. Fundamentals of Applied Electromagnetics, 6th edition, Fawaz T. Ulbe. Engineering in Electromagnetics, 2nd edition, Carl E. Longerin. Why study electromagnetics? The course is about electromagnetics, the electrical foundation of electrical and computer engineering, or how electricity really works. The electrical engineering is applied in electromagnetics. Linear circuit is a simple part of electromagnetic wave, so it was taught first. However, there are an increasing number of cases in faster computer, higher communication frequency, power electronics, power system transients, and therefore electromagnetic must supplement circuit theory. But don't worry, also electromagnetic is the basis for many devices, machinery, antenna, etc., and one of the physical foundations of any active electronic device. Get smaller and frequency get higher and higher, circuit theory is less able to adequately describe performance or to predict the operation of circuits. At very high frequencies, transmission line and guided wave theory must be used in application such as high-speed electronics, micro and nano electronics integrated circuits. Other applications include fiber optic microwave communication system, antennas and wave propagation, optical computing, electromagnetic interference, electromagnetic compatibility, biology, and medicine, biomedical imaging. As use of the electromagnetic engineers who have practical working knowledge in the area of electromagnetics continues to grow, electromagnetic engineers design high frequency or optoelectronic circuits, antennas and waveguides, electrical circuits that function properly in the presence of external interference while not interfering with other equipment. The electromagnetic technical specialty prepares future engineers for employment in industry in the area of radar, antennas, fiber optics, high frequency circuits, electromagnetic compatibility, and microwave communication. Electromagnetic is everywhere. Electromagnetic is fundamental to the advancement of electrical and computer technology. Students are well equipped to handle important practical problems in electrical and computer engineering, to gain physical intuitions about nature around themselves. Electromagnetic is the study of charge at rest or in motion. So, electromagnetic, when we are studying the charge at rest, then it is called electrostatics, or when the study of charge in motion is known as electromagnetics. So, combinedly, the electromagnetics is the study of charge at rest or in the motion under certain boundary levels or boundary conditions. The subject of electromagnetics may be divided into three branches: electrostatics, charge are at rest, no time variation; magnetostatics, charges are in steady motion, no time variation; electrodynamics, charges are in time varying motion, give rise to waves that propagate and carry energy and information. Steps in studying electromagnetics: define basic quantities, example electric field, magnetic field; define the rules of operation, mathematics of these quantities, example vector algebra, partial differential equations. Is a discipline concerned with the study of charges at rest and in motion. Electromagnetic principles are fundamental to the study of electrical engineering and physics. Electromagnetic theory is also indispensable to the understanding, analysis, and design of various electrical, electromechanical, and electronic systems. Some of the branches of study where electromagnetic principles find applications are RF communication, microwave engineering, antennas, electrical machines, satellite communication, atomic and nuclear research, radar technology, remote sensing, EMI, EMC, quantum electronics. Electromagnetic theory is prerequisites for the wide spectrum of studies in the field of electrical science and physics. Electromagnetic theory can be thought of as generalization of circuit theory. There are certain situations that can be handled exclusive in terms of field theory. The theory of relativity proposed by Einstein was such a revolutionary theory that changed the various classical concepts and general theory of relativity. The special theory with the behavior of material bodies in a frame of reference moving with constant velocity relative another frame of reference. The main aim of this theory was to solve the riddle of absolute motion of bodies while explaining the results of many experiments. Einstein found that a stationary frame of reference can not be detected even in free space. That is, absolute motion in free space is a meaningless concept. Meaningless concept. In 1915, the theory was further extended to take into account the presence of gravitational field. The theory is called General Theory of Relativity. So, laws of electrostatics. Uh, we know that the laws of electrostatics, the first law, like charges of electricity repel each, whereas unlike charges attract each. Second law of electrostatics is that the, or we can say the electrostatic law, that is force between 2 point charges is directly proportional to the product of their charges, inversely proportional to the square of the distance between them, and inversely proportional to the absolute permittivity of the surrounding medium. So it is written as F equals to K Q1 Q2 upon D square. This is known as the Coulomb's law. So uh, the difference of electric potential between 2 points is work done in moving a unit charge from point to another. So if I'm talking about the Gauss theorem states that if charge Q enclosed within a surface, the total flux crossing the surface is Q. Whatever may be the distribution of the charge enclosed, it is assumed that the medium is homogeneous. And the Faraday's law of electromagnetic inductions and the laws of magnetic force, and similar to the Coulomb's law of electrostatic force, the law of magnetic force is given as F equals to K m1 m2 upon d square, where m1 and m2 are the pole strength of any magnet. Uh, and the phenomena whereby an EMF and hence current is induced in any conductor which is cut across or is cut by a magnetic flux is known as electromagnetic induction. So the wave propagations or waveguides are the secondary things in which the electromagnetic waves are traversed, and the transmission line are the means of conveying signals or power from one point to another. So following types of the commonly used transmission lines are parallel wires and coaxial lines. And similarly, the antenna theory is also related to the electromagnetic waves or electromagnetic field theory. So electromagnetic waves are of two type signal that propagates through free space with the speed of light. The direction of electric field, the magnetic field, and the propagations are mutually perpendicular and transverse in nature. In electromagnetic waves, power density is inversely proportional to the square of the distance from the source. So next, in electromagnetic theory, the quantities involved can be categorized as source quantities and field quantities. Source of electromagnetic field is electric charge, either at rest or in motion. However, electromagnetic field may cause a redistribution of charges that in turn change the field, and hence the separation of cause and effect is not always visible. Why is electromagnetics difficult? Electric and magnetic field are three-dimensional, are vectors, vary in space and as well as in time, are governed by the partial differential equations. So we are well aware about the vector quantities, vector theory, and the Cartesian coordinates because it's a three-dimensional effect of electromagnetic wave, and they are very in space as well as in time. And most importantly, the tool, that is mathematical tool, partial differential equations, is hereby used to govern the electromagnetic field theory. Therefore, solution of electromagnetic problems require a high level of abstract thinking. A student must develop a deep physical understanding. Math is just a powerful tool. So, mathematical fundamentals now. Electric charge is a fundamental property of matter. Charge exists only in positive and negative integral multiple of electronic charge. That is E equals to 1.6 into 10 to the power minus 19 coulombs. It may be noted here that in 1962, Murray Gell-Mann hypothesized quarks as a basic fundamental building block of matter. Quarks were predicted to carry a fraction of electronic charge, and the existence of quarks have been experimentally verified. Principle of conservation of charge states that the total charge, algebraic sum of positive and negative charge of an isolated system remains unchanged through the charges may redistribute under the influence of electric field. Kirchhoff current law is an assertion of the conservative property of the charges under the implicit assumption that there is no accumulation of charge at the junction. Electromagnetic theory deals directly with the electric and magnetic field vectors, whereas circuit theory deals with the voltage and currents. Voltages and currents are integrated effects of electric and magnetic fields respectively. Electromagnetic field problems involve three space variables along with time variable, and hence the solution tends to become correspondingly complex. Vector analysis is a mathematical tool with which electromagnetic concepts are more conveniently expressed and best comprehended. Since use of vector analysis in the study of electromagnetic field theory results in real economy of time and thought, we first introduced the concept of vector analysis. Examples of electromagnetic applications. The pictorial representation of electromagnetic application, these are the some high level examples of electromagnetics. Computer technology, antenna technology, military and defense application, biomedical applications, electroencephalography measure the electrical activity produced by the brain as recorded from electrodes placed on the scalp. Just wait a minute. Yes. So double EG, that is electroencephalography, measures the electrical activity produced by the brain as recorded from the electrodes placed on the scalp. ECG, electrocardiogram, records the electrical activity of heart over time. Transportation, levitated trains, maglev prototype. So maglev train or maglev prototype is just that magnetic leviation. So in electromagnetics, the transportation in electromagnetics is a certain very high level of engineering and advanced engineering where the application of electromagnetics takes place. And as we had seen that the trains are moving on a track, but in some countries or in some is there an advancement has been done by the electromagnetic field theory with the help of this electromagnetic field theory or electromagnetics that the train is moving on the track, but it is not actually on the track. Somewhat it is having a level up, that is no friction is there and the control is governed through the electromagnetic concept, and that is known as leviated maglev train or leviated train. So it's a very high use of electromagnetics in the transportation. Localization and sensing. So to localize or just for remote sensing purposes, electromagnetic plays a very high role of instrumentation. Electromagnetic waves are transfer waves made up of electric and magnetic fields. All electromagnetic waves travel at the same speed. In vacuum, they travel at 3 into 10 to the power 8 meter per second. Different electromagnetic waves carry different amounts of energy. For example, microwaves carry less energy than X-rays. The amount of energy carried by an electromagnetic wave depends on the wavelength. The shorter the wavelength, the higher its energy. Wavelength and frequencies are linked properties of wave. The shorter the wavelength, the higher its frequency. The frequency also tells you about the energy of wave. The higher its frequency, the higher its energy. When electromagnetic waves hit a surface, they can be reflected, absorbed, or transmitted. How the wave behave depends on their energy and the type of material. For example, light waves are reflected by skin, but X-rays passes straight through the skin. When waves hit a surface, if electromagnetic waves are absorbed, some of their energy is absorbed by the material. This is usually increases the temperature of the material because the electromagnetic waves are having the nature of heating property. So they usually increase the temperature of the material also. What is the electromagnetic spectrum? The electromagnetic waves are grouped into types that have similar wavelengths and so have similar properties. Radio waves, gamma rays, X-ray, ultraviolet ray, visible light, infrared rays, and microwaves. So these are this is basically the electromagnetic spectrum. The frequency Spectrum of an electrical signal is the distribution of amplitudes and phases of each frequency component against frequency. A full range device is any audio device capable of capturing, reproducing, or processing the full audio frequency spectrum of 20 Hz to 20 kilohertz. This is the electromagnetic spectrum. As you see this, the visible is stand for Vibgyor, and all the other than the visibles are as shown as the radio waves at 3 kilohertz, microwave 300 megahertz, infrared 300 gigahertz, ultraviolet 790 terahertz, picohertz 30 gigahertz, and the gamma rays and all that. And the wavelengths are respectively given. So this is the electromagnetic spectrum. Smaller wavelength, higher frequency, and energy and hazards are there. Electromagnetic waves form a continuous series in order of changing wavelength. The frequency and energy, this series is called frequency and energy, this series is called the electromagnetic spectrum. Radio waves are the longest wavelength electromagnetic waves and mostly passes through the body. They are not strongly absorbed and are thought to have no effect on the health of living tissue. Microwaves are radio waves with short wavelength. Microwaves are radio waves of short wavelength. So microwaves are the radio waves of short wavelength, and however, the microwave produced by mobile phones have not yet been proved to cause health problems. Microwaves are widely used in radar and communication system. They are also used in industrial, scientific, and medical field. The frequencies specified in USA for these applications are 915 megahertz, 2450 megahertz, 5800 megahertz, 10525 megahertz, and 20125 megahertz. Industrial applications of microwaves include measurement of thickness of metal sheets in rolling mills, continuous measurement of diameter of wires, measurement and monitoring of moisture content, heating, cooking, and processing of food. Medical applications include diathermy, cancer treatment, etc. Doppler motion sensor use the Doppler effect, that is change of frequency of wave when reflected by moving object. Doppler motion sensor is used in vehicle speed monitors for traffic control and intrusions alarms. So the quantities required to be measured in microwave circuits are frequency, power, and impedance. Microwave frequency measurement is done by slotted line, resonant cavities, and transfer oscillators. Microwave power measurement uses bolometers and microwave power meters. A self-balancing bridge working on the principle of power substitution is commonly used. Microwave impedance measurement is done by the measurement of application or reflection coefficient and voltage standing wave ratio. A slotted line and probe is basic tool for these measurements. Network analyzers enable rapid impedance measurement over a broad frequency range. Next, how do infrared waves affect humans? Infrared waves are absorbed by skin to limited depth. They transfer their energy to the skin tissue, warming it up. This heating effect is detected by temperature sensitive nerves ending in the skin. If the skin is exposed to too many high energy infrared waves, it will be burnt. Your eyes detect visible light, which does not normally pose any health risk. However, very bright light can damage your eyes and may even make you blind. This is why you should not look at sun through a telescope or binoculars. Lasers are very intense source of visible light. The lasers used in the light shows are not powerful enough. The lasers used in light shows are not powerful enough to cause harm, but must be used safely. Laser, as basically we know that laser stand for light amplification by stimulated emission of radiation. So all the conventional sources of light are an aggregate of atomic oscillators operating independently of each other. Atoms are continuously excited to higher energy levels. From there, they fall back spontaneously to their ground state, emitting photons, and remains in excited state for nearly very short time. And after that, atoms come back to its ground state. The lack of correlation in wave trains at different times at given point is called temporal incoherence. So, laser source produce a highly intense and truly monochromatic due to temporal coherence beam. How it is achieved, the answer is explicit from the name itself. As you know, that laser stands for light amplification by stimulated emission of radiation. The action of laser was first proposed by Einstein in 1917, but Towns was the first to use the principle of laser. Towns was the first which is used the laser. In 1954, in the amplification of microwaves. This device is called maser. In 1958, Townshalo and Bosov Prokhorov used this principle in light amplification. Myman in 1960 developed a laser source using ruby crystal. So, some very powerful lasers can cut through materials such as metal. These would also be able to burn through living tissues. In thermal equilibrium, the population of atoms in different state is governed by Maxwell-Boltzmann law, and the rate of transmission of atoms by absorption of radiation is equal to the rate of transition. by total emission of radiation. In the presence of incident radiation, an equilibrium is distributed or disturbed, and the ratio of emission absorptions. So we can say that the emission rate must be larger than the absorption rate. The probability spontaneous emission which produce in coherent radiation must be very much smaller than the probability stimulated radiation for lasers. And there is a methods of pumping for the inversion population density of atoms. Basically, the inversion population is a phenomena which is to be created for creating the laser light. So there are certain methods of pumping. One is optical pumping, electron impact, inelastic atom-atom collision, chemical pumping, gas dynamic pumping. But the most natural is the optical pumping, which is utilized by ruby laser. And suppose, and one more question is there, why do we need more than two energy levels for laser action? Suppose there are only two states, one is excited metastable state and other is ground state. When we pump the atoms from the ground state to the metastable state, more and more atoms will be collected at the metastable state due to its longer lifetime. But at the same time, the pumping will induce downward transition from metastable state to ground state. When the population density of both states become equal, then the rate of induced emission equals the rate of induced absorption. In such case, the further increase in population density of metastable state ceases, and so laser amplification stops. By taking another usual excited state, and the lifetime is very short, higher than that of a metastable state, rate of induced emission from metastable state is made higher than that of induced absorption from that usual excited state. Atoms are transferred by collision or by other means, spontaneous emission, to the metastable state, where induced emission occurs in the form of coherent radiation. So the laser beams have some specific properties in comparison of ordinary light beam. Due to this reason, laser finds wide application in different branches of science, technology, and medical applications. Some specific properties of lasers are they are very intense and they are very highly directional and highly monochromatic and highly spatial and temporal coherent. The high intensity of laser beam is due to the fact that the photon produced by stimulated emission is always in phase with the incident photon. Thus, at every step, this phase relationship is maintained. So, these are some project themes. One is the global positioning system, GPS, microwave imaging, plasma, mobile phone technology, microwave and satellite communication. These are some references which I had already discussed and get you to look into some reference. Matthew N.O. Sadiq and the NPTEL website where you can get the course and the video lecture. Now, questions or questionnaire time, quiz time. There are some MCQs are here to discuss based on the electromagnetic field theory. So first, the energy of the discrete particles can be given by photons, protoplasm, electrons, neutrons. So choose the appropriate word. Energy of the discrete particles can be given by photons or protoplasm, or electrons or neutrons. Next, which among the following is more wavelength? X-ray, cosmic waves, radio waves, gamma rays. So which of the following is having more wavelength? We had already discussed the spectrum of electromagnetic waves. So just go through the slides once again and check it out, which will having more wavelength. Optical mechanical scanner is used in which type of electromagnetic waves? X-ray, cosmic waves, radio waves, thermal, infrared. So choose the appropriate answer. Gamma rays are having a wavelength of, so choose the appropriate answer. The gamma rays are having a wavelength of 0, greater than 0.03 nanometers, less than 0.03 nanometers, equal to 0.03 nanometers. Which of the following waves can be used in cause of remote sensing? Ultraviolet rays, X-rays, gamma rays, visible rays. Which of the following indicates the correct set of combination of radio waves? Shorter wavelength, high frequency, longer wavelength, less frequency, shorter wavelength, less frequency, longer wavelength, high frequency. So just set, choose a combination of radio waves, correct set. Electromagnetic waves varies from meters to nanometers, meters to micrometers, nano to micrometers, centimeters to nanometers. Choose the appropriate answer. The formula of energy produced from the body can be given as Q equals to H minus C by lambda, HC, H into C into C, H plus C by lambda, or Q equals to C by lambda. Choose the appropriate answer. The following are the electromagnetic waves except infrared waves, gamma waves, sound waves, radio waves. A wave that consists of two perpendicular transfer waves with one component of the wave being a vibrating electric field and other being a corresponding magnetic field is called induction wave, radiant wave, sound wave, electromagnetic wave. So choose the appropriate right answer, and everyone knows that it is electromagnetic wave which are having two components and they are perpendicular to each other vibrating in the propagation direction, and it is perpendicular to the propagating direction also. So D is the right answer. Which of the following parameters is not a primary parameter? Resistance, attenuation constants, capacitance, conductance. So answer B is the right answer, attenuation constant. Which primary parameter is uniformly distributed along the length of the conductor? G, C, L, R. So the perfect answer is right, that is D, R, resistance. The leakage current in the transmission line is referred to as, so answer C is the appropriate answer, or right answer, conductance. The reflection coefficient of wave with transmission coefficient 0.35 is 1.35, 0.65, 0.35, 0.7. So the answer is B, right answer, 0.65, and the explanation is given in the solution is given. Just go through the solution and get the answer. In matched line, the transmission coefficient is 0, 1, minus 1, infinity. Answer B is right, that is 1. Choose which of the following condition is not required for waveguide to exist. The dimension should be in an accordance with the desired frequency. Cutoff frequency should be minimum 6 gigahertz. The shape should be spherical. And the fourth one is the no specific condition is required for waveguide design. Answer C is the right answer. Which of the following are conductors? Ceramics, plastics, mercury, rubber. Mercury. Find the range of band gap energy for conductors. So, answer B is the right answer. 0.2 to 0.4 electron volt is the energy band gap for the conductors. Or almost we can say that it's very less or very few. It's near about to zero also. Conduction in materials or metals is due to electrons only, electrons and holes only, applied electric field. So everyone knows that conduction in metal is due to the electrons only. Alternating current measured in transmission line will be peak value, average value, RMS value, or zero. Obviously, it is the root mean square value. The C is the right answer. So, this is all about the introduction of electromagnetic field theory. Now, in next lecture, we are going to study about the Maxwell's equation or Maxwell's boundary equation related to the starting from the uh, electromagnetic field theory as a part of electromagnetic field theory. So, thank you all. Thank you all for this today's lecture. Have a nice day.